So here's where we're going. Here's the agenda. The QR code for the notebook we are using is at the bottom here, and I'll also throw this notebook link into chat as well. Um, am I with everyone? Yeah. It is stored in Google Colab. It should be available to view anyone with the link. Again, your ability to run it and click through it is going to depend on your what resources you have access to in Colab. Some people they find that if they just kind of copy the cells themselves and run on their own workstation, that's often easier. So just again, a little bit of nuance there. But ultimately, the notebook is meant to be kind of some of the practical code and steps you can do if you want to follow along. And I'll be demoing those as well as we go through. The pillars of what we discuss today is going to be talking about just a little bit of background, like what is 51, or maybe more accurately, why is 51. Next, we will talk about the application architecture itself. So 51 at its core is a collection of a few components and libraries. It's ultimately served as a client-server application. So there's a portion that we call the app, there's the core SDK, and then there's an algorithmic portion called 51 Brain that allows you to do things like compute embeddings, uniqueness indexes, and other things. Then we'll talk about some of kind of the core aspects of 51. Now, one of the kind of claims to fame with 51 is what we call advanced data curation. So the idea is it provides an intuitive interface to really dig into your data, both labeled and unlabeled, right? Sort, filter, slice your data into whatever view is needed for you to act on, especially for doing things like finding unique data, finding outliers, identifying failure modes that your model might not perform well on. And then we'll kind of talk about what we call a core loop of curate, annotate, and evaluate. So 51 allows for, again, those what we call those data curation aspects. It also includes in-app annotation. And then when you train and run models, there's also a lot of kind of core evaluation capabilities as well when it comes to comparing model predictions versus ground truth and so forth. And then lastly, because it's the big 2026, agentic AI is both inevitable, but honestly quite helpful in this regard, especially if you're onboarding to the platform. So we include some resources around 51 skills, a 51 MCP server, integration with your agentic tools and coding harnesses, as well as a couple of additional features as well that I will talk about. From an interaction standpoint, I should mention this as well. If you look in Zoom, there's the three dots on the toolbar. So the same toolbar where you have like chat and so on. There should be three dots that say more and then a Q&A panel. If I might ask, if you have like, specific questions as I go through, feel free to use that Q&A panel to ask it. You obviously have access to the chat as well. It's just the Q&A panel makes it a little bit easier for us to follow along and mark what needs to be answered and what has been answered. And then on that point as well, joining me on this call is my colleague Burhan. He's the one who said how he's joining from Hot Town, USA. Burhan is also on the community team. He'll be assisting with answering questions as well. If you join our 51 community Discord, which I'll make mention of towards the end of the talk today as sort of some additional resources. He is always there, making sure that questions are answered and that, everyone continues to be hyped around what can be done in the computer vision community. And I see Baran just put a link to the Discord community there as well. Okay, we are going to go ahead and get started. We have a lot to cover over the next 50 minutes. Now, again, you're in the right place if this is, if you're interested in working with unstructured data, particularly images, video 3D, particularly visual data for training and evaluating models. If you come from the angle that, hey, I think it's my data limiting me, not so much my model architecture, that's a core kind of thesis that we put forward as well. On top of that, there's kind of a catchphrase we use. I'm actually wearing the corresponding shirt, if you can see it. It's data eats models for lunch, right? So we are rather opinionated on the concept that the big limiter, at least at the moment, of model performance is the training data. And especially those edge cases and failure modes that cause models to underperform on critical scenarios. This is not a computer vision theory workshop. This isn't really a Python fundamentals workshop. Um, this is more focused on practical application using 51. And to the question just in chat as well, yes, you'll receive all materials. Afterwards, there'll be a follow-up email sent out, including the recording, uh, uh, slide deck, notebook, and some additional resources also. Okay. On this right is good old Satya Nadella, CEO of Microsoft. Basically, and this is kind of something, that's been kind of talked about for a little bit now, is that in the vision language space, especially, it's still somewhat controversial, right? Model architecture is still critically important, but there is an idea that, models are progressively getting commoditized, and that the focus on data is really what's going to be a differentiator, especially the more domain specific your application is. I think that should go without saying. So basically unlocking the ability to both understand and feed, the appropriate and quality data into your model training cycle is what's going to be most important. But ultimately, working with visual data is hard, right? So, like especially when you're trying to track model errors back to bad data, the software used, there's sometimes just a lack of maturity in the marketplace, right? You might be like going through just CSVs and Excel files. You might literally be like working with like File Explorer to kind of like move data around. You might be, doing the usual, this directory is tagged version 1, this directory is tagged version 2. And basically, like what would be helpful is kind of a unified interface. Think of like an IDE for managing your visual data sets. And then on top of that, again, just one more of kind of these sorts of slides, like really what you need is the right data, right? So like if you understand what slices of data are causing models to underperform, then you can address those directly. Otherwise, you're in a garbage in, garbage out scenario, right? If you're working with duplicated data, data that is poorly labeled, data that is, not clear in terms of the objects in question, you want to train your model or scenes in question you want to train your models to recognize. Again, that'll just like poison your model training from the beginning. So, what then is 51? At its core, 51 is an open source toolkit for visualizing, analyzing, annotating, and evaluating your data sets. Um, from a terminology perspective, we kind of divide our language into three core components of the platform. When I talk about the user interface, the term we use is the app. So the app is actually what gets served as a local web server. You can open it up in your web browser, generally over like localhost or something. And that's where within the UI, you can interact with your data set. When we refer to 51 Brain, that is the library powering some of the core quantitative operations like embeddings space generation, computing a similarity index, computing what we call uniqueness and mistakenness scores, running a model evaluation routines. Those are like generating the quantitative uh, metadata that matters in your data set. And then lastly, all of it is powered by an underlying library that we call the 51 SDK or the 51 library. What you'll learn pretty quickly is that your typical core workflow is that everything can effectively be done with the SDK. Like there's a programmatic interface to everything you can do. And then some things you might do with the SDK and then visualize with the app, the UI. There are some things that you can do in the UI that you can also, and then obviously you can also do in the SDK. So think as the SDK as like the ultimate superset of everything you can do in 51. So where 51 is intended to sit, I used kind of the term IDE earlier. It's meant to sit between your data and your models, right? So you have your data and it lives somewhere. In the open source version of 51, that would generally be like a traditional file system. In like the scaled out enterprise version, think cloud storage, data lake, vector databases, right? Some sort of hyperscale data infrastructure. And then ultimately from that data, you train models, right? And then you deploy your models somewhere. FiftyOne is meant to sit in the middle. Um, it's a meant to be a visual and multimodal data engine to perform, again, what we call curation, to inspect, manage, create, views and slices of your data set, perform labeling and annotation through a variety of modalities, and then ultimately evaluate your data set uh, and then debug models in the process. And we'll address all of these. Okay. Um, in a moment, we'll go over to the notebook to kind of go through the getting started part. I do want to mention that FiftyOne is deliberately highly multimodal in its support. So just as a few examples, we have, and it's not even mentioned here, we have from an image standpoint, classification, semantic and instance segmentation, object detection. The metadata is extremely flexible, so you can create and use any type of attributes you might want to define at a metadata level. So that includes support for things like medical and DICOM data sets. Through what we call GROUP data sets, we have 3D and point cloud views, and then we have multiple scene views grouped together within a single sample. This is an example in the automotive space. Um, Geospatial, you can map things like overhead scenes to GPS coordinates and show them side by side. And then audio is largely a reflection of the fact that we support, visual data. You can that inherently means we support audio data in the form of spectrograms. Also included is video, temporal tracking, and some other things as well that we're constantly developing. So, how do we get started? Well, that's where I want to go over to the notebook here to, sorry, I need to sign in for a second. Apologies about that. This is where I quickly signed out here for the moment. Sorry about that. Let me reshare. All right. So I'm actually going to go to the top here. If we look at the notebook, this is kind of the order of operations. And again, we won't go through 100% of these just due to the time that we have, but we'll go through as much as possible. And again, you'll have this as a reference. We're going to start by installing and importing FiftyOne. And this cell is a little bit janky just due to this collab environment that I happen to be working with. This first bash command, pip install FiftyOne, and then a few dependent libraries is the most important one. So again, you can run this either in your own environment, or if you have like, a Jupyter Notebook instance, you can spin that up. But ultimately, it's just installing the FiftyOne library. And I already pre-ran this just because it takes a few minutes to like resolve dependencies and the relevant libraries. Then we import the core library. So FiftyOne is, the core SDK library. FiftyOne Brain is that library that includes routines for embeddings, evaluation, and so forth. And then FiftyOne Zoo, I haven't made mention of. It is a sub-library of FiftyOne that allows us to connect to a public set of common data sets that FiftyOne maintains support for. So we have what's called a dataset zoo and a model zoo. And really what that means is that they're data sets that FiftyOne maintains connections to in a way that you can easily import through like a single method, which we'll do in a minute. And then this command or this print statement just prints the current version. So the last one I kind of pre-ran here is I'm loading a zoo data set called Quick Start. And all the Quick Start data set is it is a subset of the Cocoa data set of just about 200 samples. So here I downloaded the data set. Notice it just downloaded into my workspace's local file system. It's a combination of media and metadata. Here I output some of the core metrics. So again, the name is Quick Start. The media type is just 2D image. There's 200 samples. And then here are some of the sample fields that we'll see in the UI in a moment as well. And then last thing that I'll just do programmatically starting off is if we just look at the first sample, we can see that these are the attributes that go with it, right? There's a sample ID. We can see some of the bounding boxes and their coordinates that have been created on a sample. And we can see kind of the full, object representation of it. The next step then is to view in FiftyOne. And then typically this opens over localhost. Might take a second in this collab environment. It should, oh no, I'll try again. There we go. Um, Sometimes it takes a second. So here, basically, if you're running on your terminal, you would get an output like this. And then after a few moments, here I'm running in a notebook. It'll serve and be available over localhost 5151. And it might take a minute here the first time it loads just because of this collab environment. So while this loads, I'm actually going to go off to the side here and show you what ultimately the UI looks like. So this is just a slightly different instance here for a moment. Again, this might take just a second to spin up here in this compute environment. But ultimately, this is what the quick start data set looks like. So again, it's a selection of 200 samples from the Cocoa data set. Each have several fields. There's actually a few I added here in this instance, but there's ground truth and sample model predictions. So if I uncheck some of these fields, I can see here are the ground truth uh, bounding boxes. Give me 1 second here. That we see here, for example. All right, is this spun up yet? Again, sometimes it takes a minute. There we go. Yeah, I made this pretty idempotent, so it shouldn't be an issue with most of these if you just rerun the cell if needed. Here's what it looks like at the core open source version. So here we can see, again, let me reset my screen here for a second. Yeah. So here is the core open source version. We can see the different samples. Again, at its core are two label fields, ground truth and predictions. Couple things I can do here at the beginning. I can open an individual sample by clicking on it, right? So we can see here, we can see our bounding boxes overlaid. We can see ground truth, we can see predictions. Later, I'll talk about the annotate tab, and this is where we can actually modify the labels by reading in the existing schema. More on that in a minute. Over here on the left, there's sort of a arbitrary amount of filtering that we can do. So for example, we have what's called a uniqueness score that's already been pre-computed. I could say, okay, what are the most unique samples? We'll start with a minimum of 0.7, and then we can see there's around 15 samples here that relative to the other samples we consider to be most unique. And ultimately, this is being served again from media in a local directory. Now, as I mentioned before, let me go ahead. I think there's a little bit of this going on here. As I mentioned before, some of the core curation aspects can be done through the SDK as well. In fact, especially in the open source version, the UI often becomes like your visual confirmation object of some of like the core programmatic things you would do within the SDK. So again, this is just the curate, annotate, evaluate loop I talked about earlier. But once you use import 51 as FO and you start working with your data set, what you can do is you can start performing operations on the data set and creating what's called views that represent a query over your data. So a pretty typical approach is, again, within Python, you would import 51, you would load in a data set. What we did is we kind of cheated and loaded in a pre-made data set in our dataset zoo. But if you're like launching your data set from scratch and you're pointing to existing samples in a file path, it would look something like this. And then once you start, performing some of the various operations, you can then create a view that serves a particular slice of your data within 51 and will re-render the app in the web browser showing that data, which again, we'll look at here in just a few moments. But basically, it's a pretty typical approach where do steps programmatically, and then what you do in code shows up live in the app. And again, a lot of these are powered by what we call 51 brain. So some of like the core querying of like, filtering your samples, that's just, native Python object interaction. But algorithms like embeddings computation, uniqueness computation, mistake, what we call mistakenness, those are machine learning powered routines that are meant to like, again, generate some core quantitative attributes that you can review. Again, we'll do a few of those here in the notebook in a moment. Okay, so going back to the notebook for a moment, let's look at the querying and curating your data set section. And all we're going to do is we're just going to do a little bit of like programmatic exploration. So we previously created this data set object, and we can see that this returns the schema of the data set object and the fields that are defined in this quick start data set, most of which are adopted from the Cocoa data set. And then we can start to filter through this. For example, we can say what object classes are inner ground truth. So we can say, okay, we can create this classes variable and set it equal to this filter. So ground truth dot detections dot label, and then we can, in this example, oh, actually we're printing the first 15 of what's ultimately 71 classes. And again, these are just everyday objects because it's the Cocoa data set. But then we might filter further. We might say, okay, maybe we only want to include samples that contain person detections. And then what we're actually doing is we're creating a view out of this. So we're creating person view, and then we're setting it to the filter of samples that just contain person detections. And then we see this view created that only contains samples with people in them. So again, most of these samples have multiple objects detected, but all of these samples have at least one person as part of the detections. And then we can see at the top what was created is called a view stage. So this view stage is this, I repeat myself, this view created in 51. And what's nice about this is you can actually save this view as a reproducible object. So if you click Save Current Filters as View, let's say samples with people, it then becomes part of a list of these saved views that you can switch to if needed within your data set. And then now recall that I have this predictions field pre-applied. So the assumption is, hey, we have ground truth, but we also at one point ran a model against this data set, and it created this predictions field. And because these are model predictions, there are confidence scores right across the various detections. So what we can do is we can create a new filter that says, I only want to show samples that contain predictions with a confidence level greater than 0.9. So now this creates yet another view that we're calling high conf view, and it contains those samples. Now, this is a bit of a strange example because a lot of these samples are very busy, right? So there's likely to be at least one detection with high confidence. So it says, okay, 192 out of the 200 contain those sample views. But we'll do another example, what's called patch views in a moment, which will allow us to zoom in on the individual objects and treat them as discrete samples. And then just a couple other examples. This example shows busy images, which we define as having more than 5 ground truth detections. So let me run that and kind of reset my view here. Sorry about that. There we go. So notice we've now whittled it down to 73 samples. And as it suggests, this view based off this match says, okay, if there are more than 5 ground truth detections, we'll call it a busy sample. And then we're seeing those examples here. Again, some of them are quite busy. And then lastly, we're going to sort this, right? So we're going to basically sort our samples by busiest first at the prediction level. So we're going to say sort by order of predictions, where it's showing the samples with most predictions first. So we see, again, extra busy samples here. And then finally, We talked about how you can create a view, which is just a stage of samples applied to a particular filter. You can also create what's called a tag, which are individual labels, not like detection, like annotation labels, but sample level labels, attributes that you can set as a referenceable piece of metadata later. So, for example, we might say samples that contain objects with a model confidence of less than 0.3. We'll call a low confidence view and then tag these samples as low confidence, which again, a bit of a weird data set. 187 samples have it, at least one sample with a detection with a confidence less than 0.3, but you get the idea. Okay. So again, one of the initial ways you can start to kind of work with these data sets is through what we call curation. It allows you to kind of filter, match, sort, select samples, etc. Now, everything we showed so far is in the open source 51. Couple just things I want to reference that are in what we call 51 Enterprise. Let me jump over to here for a moment. Is what we call the data quality tab. So the data quality tab allows you to compute core metrics like brightness, blurriness, aspect ratio, and then see like a histogram of allowing you to sort your data by these metrics. So for example, if I were to compute brightness against this data set, so for example, I can put it side by side here. Just want to be a little bit slow today. Let me try blurriness. There we go. Maybe I'll scan data set for blurriness. I will execute this against a connected GPU orchestrator, and I'll kind of leave this alone for a little bit. That allows us to, again, get a blurriness distribution on our data set. I don't know why it's taking a little bit to load here. Let's see if this run started. No, not yet. Like a little bit of slowness here today. Today's a release day at Voxel 51, so there's a possibility that that's because this is a production instance. That's where some of the slowness is coming from. But if I actually go back here to this data set, I can see, let's see, there's uniqueness, frames, mistakenness. Okay, there's some other things I can look at here in a moment. So yeah, it might be just part of the fact that yeah, there we go. Okay, scan was now scheduled. So I'll let that run in the background. Again, this is something that's part of 51 Enterprise, this sort of embedded panel of this routine, but there's some programmatic stuff here we'll do in a second as well. Okay, so let me actually go back to the notebook here to the next example. And let's talk about one of the core things that are helpful in visualizing data sets, which is computing and visualizing embeddings. So that's one of the computational methods that are available within the 51 brain library. There's a couple of layers to it. Number one is there are default root like algorithms you can use. For example, I think it uses UMAP as the default, but you can ultimately plug in your own embeddings generation tool if you would like. What you then do is you save the embeddings run as a key, and then you select that key in the UI that allows you to view the embeddings you generated. So here, I'm just going to run the default compute embeddings against the data set. And then that'll generate the embedding space that I'll get to review in the app in just a moment. And if this takes too long, I'll show the equivalent on my other tab here. Yeah, it looks like it's going pretty quickly. So once this finishes here in a second, what's helpful about this is the embeddings will become a lassoable endpoint. And from there, it allows you to qualitatively identify things like outliers, distribution of your data based on a particular field. What are samples that look unique? What are samples that are like clustered together that shouldn't be? So that can help you identify where do I need to find better distribution and coverage in my data set. But it also allows you to do things like select, okay, if my, you know, labels are clustered together in a weird way, maybe there are some labeling problems I need to identify. All right, so this should just be finishing up here. And then in a moment, once this stops spinning, this will become directly within the 51 app, something I can select and view. So again, we'll give it here just a minute. If it goes another 15 seconds or so, I'll hop over to the other tab. Yeah, this is using, it's a small data set, but this Colab notebook, I think, is using a CPU backend that probably I should have made GPU or give it a little bit more juice. Okay, this is done. Now I'll go ahead and open the app. So actually, I need to scroll back up here. Sorry about that. I didn't do a separate render here. So looking back at my quick start data set here, I'll just reload it. I should now see this in this embeddings tab, this key that I just generated. And then side by side, I can see the embedding space next to my samples. Now, again, this data set is very like diverse. So the interestingness of this embedding space might not be too crazy. So for example, I can like filter by, or rather I can color by uniqueness, for example, and I can look at my least and most unique samples and lasso an area of it. And then when I lasso an area, that will this wants to reset. I'll show something else in a second. I think this is the notebook being a little bit janky. It'll filter that area. Let me show you what I think is a better example. Yeah, we can see these here, where I'm going to go into an automotive data set, which is just going to be the Berkeley Deep Drive data set. Let me go to BDD 100 or 10K. I'll just say BDD. We have several subsets of the Berkeley Deep Drive, but the embedding space is much more interesting in this one. Let's do BDD 2K. That should be interesting. So this is all like drive scene data. And then if I open up the embeddings computed here, this is actually a little bit different. These are actually model predictions visualized. Or actually, sorry, no, this is the embeddings. But what I can do is I can then filter these by like, let's see. This isn't a good example. I apologize. Let me go back one more to the one I want to show here. Do one more here. I'll do BDD 10K. Embeddings, image viz. There we go. Okay. This is a good example. So this looks like a lung x-ray. It's kind of funny. So, this automotive data set, we have two big clusters. These are just generated from the raw sample images themselves. And we can see, you can probably guess one of these clusters correspond to daytime samples, another corresponds to nighttime samples. If I color these clusters by, let's do time of day dot label, we can see that distribution here, right? On the left is nighttime, that tan. On the right is daytime here. So then what I could do is I could look at outliers. Like, why is there this cluster like way over here, right? What might that represent? Well, for whatever reason, this represents like this kind of weird, oh, it's occlusion, right? So here the dashboard is like occluding the camera. If I reset my embeddings view, I don't know why my little cursor is sticking there, by the way, and I go back, I might say, hey, maybe there's something over here, right? In this nighttime view, right? And I could see, looks like there's some like, GPS stuff on here, a tablet and like other things in the way that might be causing this view. Again, I'll do one more down here. I see I need to reset my screen here in a second. right? And here these are like rainy samples, right? So again, at minimum, it allows us to like surface outliers in a qualitative way. All right, so going back down here, view embeddings in the app. Now, extra helpful can be this concept I made mention of earlier called patch embeddings. So remember that all of these samples have like multiple detections. When you're trying to evaluate the quality of models on an individual detection basis, well, the whole sample, right, might not be a good way to do it. It might be helpful if we can splice this out for like one sample per detection and visualize embeddings that way. So I'm going to do it here. What I'm going to do is I'm going to create what's called a patches field and then generate embeddings from that. While that's going, I'm going to simultaneously, give me 1 second here, go back here and show how it can be done in the app as well with what's called a two patches operation. I can select detections and it's going to generate a patches view for each label. So I'll let that run as well. So now it's resetting and notice now there's individual samples kind of zoom in for every label. And then if I now show the embeddings view, I can now select, let me zoom in here for a second. I know I'm zoomed in again. I can select kind of a particular area to zoom in on at the patches view level. All right, looks like this is just finishing up as well. So again, what can be helpful there is then you can start to treat your individual detections as patches likewise. All right, it's almost there. Yeah, not the most amount of juice on this system. Right, now it's generating the visualization. That's normally pretty quick. And now, again, in the quick start view, if I look in the app, we can now see the patches view like so. Again, with in this case, the uniqueness sort I did over off to the side here. Notice though, like again, it's like multiple views per sample, like so. Okay. And then last thing I'm going to do, what could be helpful, is use another brain method to perform what's called a similarity index build. So what I can then do is, and again, this will take a minute, so I'll move on here in a second. But what allows us to do is then query by similar objects. So for example, going back to this for a moment, let's see if there's a similarity index on quick start here. I just want to do regular quick start. There we go. Yeah. So I might say, cats. Right? And because we built the similarity index, in a moment it should sort this data set by cats or whatever I put there, people walking down the street at night or something like that. And right, did an okay job. Not the best. Or I guess it's showing samples that things are similar. So lots of animals and things like that. Again, part of this will be dependent on what model you use. I don't know the default that was used here. Okay. All right, so I'm going to skip ahead a little bit and talk a little bit more about the dataset object. And I want to talk about kind of the loop of curate, annotate, evaluate. So we've pretty much talked about curation up to this point, and I would argue that is like kind of one of the core have to do areas in the platform, which is why I spent so much time on it, because everything downstream depends on it, right? So when it comes to things like data set curation or an annotation, that's going to depend on making sure you have access to and understand your data, both labeled and unlabeled in the first place. So as I said before, you ultimately have a data set object. It includes sample media. It includes field. Ultimately, 51 has a MongoDB backend, database backend that allows you to quickly, perform database queries on your data. From the labeling side, there is now quite a bit of in-app support for um, labeling. So if I go back to my notebook here and I'll just look at one of the open samples, let me kind of reorganize myself here for a moment. I'm just going to reload this quick start data set. Let's pretend it's completely unlabeled, right? So we have unlabeled data. We'll start there. If I open a sample, like maybe this cowboy person on a horse, and I go to annotate, I can set up what's called a schema, which I can either um, start from scratch. So I can define my field name, the label type, the classes I want, the different attributes, or I can scan an existing schema, like maybe the schema used by ground truth, right? So I can just scan that in. There we go. Hold on. Let me set up, scan, add attribute. That should. Oh, I need to give it a, I need, see, it's not read only. Field type is detections. There we go. I don't know why I was taking a moment. Let's go back here for a second. And then if I go to active fields, I don't know why this is not behaving. Let me try one more time. I'll go to my other instance here in a moment. Set up. It's not read only. I'm not using a new ontology. Classes. Oh, I need to save it. That's why. There's just a lot of them. To save. That's why. Sorry about that. And now, right, we can see this is the existing. And if I want to create new labels, I could just create a new detection. Like, I don't know. I could call it forest or something if that was one of my classes, right? Or like tree if there's one here, or I don't know. Right? I don't think there is that example. Or I can modify existing labels, right? So I can, again, this is just the example of, object detections here. And then I can change attributes, right? So maybe like, I don't know, this is not a person. Let's pretend incorrectly that this person is, I don't know, a dog, right? And then the label is applied. Now, there's broader project management that we can do here that has just been released in the newest release of 51. So for those that are interested in more team-based project management, in 51 Enterprise, let me go here, there's this annotate tab where you can create workflows of labeling. So I can create like an annotate review workflow. And then when I start the workflow, it'll create tasks that then an annotator can go in and then drop themselves into the task. Now, what's nice about that is with this kind of task review method, as these tasks start to load, as the annotator goes in, yeah, good point on relabeling the cowboy. I could have added an additional attribute, right? If I'm doing, an annotation here, maybe I'll kind of set this up. Again, we have this bird schema. Maybe this like object is like poorly designed, or maybe I'm like, this is not a bird at all. This is a chicken, or it might be like a specific, more of a specific thing, right? Or maybe I just might, adjust this, for example, right? This will carry us through and, submit next, 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 next. Here's the horse again. Maybe I'll just delete this label entirely. Again, kind of just a basic example here. And then let's say, I've only labeled two so far, but going back to the annotate pan, you'll notice that 2 of 200 are labeled for my annotators. And now in the review stream, right now there's two ready for review. And as a reviewer, I can go in and again, looking specifically at what the annotators did here, I can choose to like accept or reject with comment. So I might be like, no, this is bad. Like I might, you know, bounding box on right bird not tight enough. And I can reject this one. And just to show another example, let's pretend that I approved this one. Right now, I've deleted a label. This is wrong, but let's say I approve this. The one I rejected gets sent back to the annotators queue. The one I approved moves forward. So notice I see them labeled here, rejected and approved. And then back in my annotate tab, looking at the tasks, I can see one was sent to final review. The number of that we annotated and is done from an annotation standpoint is now down to 1 out of 200, right? Because the annotator labeled two, we approved one of them and we sent one back, right? So out of the 200, only one is considered done. The other was sent back, so there's still 199 to go, right? In terms of the annotator. So this is, again, something that's we actually are just in the process of releasing this kind of broader workflow management in 51 Enterprise. Whoa. 51 also 51 also nicely shows Python traces in the app as well. How nice of it. um, okay. So looking at the time, moving on to um, a couple other things. I just kind of want to make mention of two things here. One, just for when it comes to annotation here in a moment, we do have like wide multimodality support. So I only gave you a taste of really what's object detection, but we have instance segmentation, object detection, 3D LiDAR, what we call grouped data sets, cuboids, 3D polylines. Um, these are 2D polylines in this example. Here's 3D polylines. So there is quite a lot of multimodal support, but structurally it works the same way in terms of these annotation flows. Right, so here's an example of like segmentation. All right. Okay. Couple remaining things that I want to discuss. The first is, remember I said the loop is curate, then annotate, then evaluate, right? So I discussed curate. I touched on the annotation workflows. I next want to talk about evaluation. So another one, and I'm actually going to skip over to here for a second, of what I call the 51 brain methods. Let me do this here, is let me go into my BDD data set for this one. Is model evaluation. So again, the assumption is, let's say you have a model that you've trained and there are predictions on that model. You can then run your core metrics with respect to ground truth. So for example, in this automotive data set, and I'll show another example of a data set in a second, we ran a model against the data set. It runs object detection inference, and then here are the core metrics, right? Not awesome, right? Here's confidence, intersection over union, precision, recall, F1, so harmonic mean of precision and recall. We can show the class performance of what happened to be in this data set that was detected. We can see a confusion matrix of where it might have been confused between objects. Yeah, not a lot of object confusion here. I'll show another example in a second. But if I click any of these like visual attributes, for example, like here are true positives of car, for example, right? It'll filter the data set accordingly based off the confusion matrix. I want to show you another example that I think is in a different industry, and that is anomaly detection. So this is an industrial data set called MVTech, and it has a lot of segmentation masks, so it takes a little bit slower to load. But here we've actually run two models. And this one is pretty straightforward. These two models just ran a binary classification of detective versus not detective. So we ran two common models used for this purpose of PATM and patch core. So for example, here is again, Here we have like defect masks on some samples, which actually doesn't really show much under the under this like semiconductor version, but I'll show you an example here in a second. Let me actually do this. Let me open up my model evaluation here off to the side. And here we can see these runs for every category of these industrial objects with both PATM and patch-core models run against it. So let's look at metal nut. So here we have the PATM eval for metal nut, and I'm going to compare it with the patch-core eval for metal nut. And then here we can see where each model performed better. Here we can see the patch-core model like won pretty outright. We can see the metric performance, class performance, and then the confusion matrices. And again, if I kind of expand this out a little bit, right, we can see where, okay, here's where patch core, the few cases where it, confused anomaly versus normal, where if I click into one of these, we can see that patch core falsely categorized. Sorry, patch core says anomaly, but the ground truth says it's normal, right? So this is a false positive. And we can see there were three of them in this case. So again, part of the goal here is by having this side by side with the data, you can make that, you can start to do these distinctions. And I don't have time to show it, but there are quite a few additional features of this. One of them is called scenario analysis, where you can look at model performance with respect to a specific slice of your data, like maybe rainy conditions with people in the camera view. And you can do all these same stuff just against a very specific sliced filter of your data set. All right. Very last thing I want to discuss here is I covered a lot and quickly. Um, FiftyOne, there's a lot going on with FiftyOne. There's an SDK, so there's basically a whole kind of Python language and framework to learn. There's understanding the nuances of the FiftyOne app. There's understanding all that's possible with the different features like embeddings, model eval, uniqueness. There's a lot of stuff haven't even discussed around like mistakenness and some other curative tools. A good way to get started is to, because FiftyOne is so both programmatic and composable, is to use it with your coding assistant. So FiftyOne has a dedicated skills repo in GitHub called FiftyOne Skills. It's open source, right? It's open. You can download it for free. And this is effectively a skills marketplace that you can add, to your coding assistant. So for example, if I spin up my own instance of Claude, let me just go off to the side here. Right here, I have my little Claude code. I typed skills. I just typed /skills. Here I see all these FiftyOne skills that I've installed from the skills marketplace. If you're more of like the MCP server, and if that's something you like as well, we do have a FiftyOne MCP server that you can install as well. Also something you can install and use with the open source version. So again, that's a way to hook FiftyOne skills into your coding harnesses so you don't have to remember the exact like SDK objects and methods. You can just be like, describe my data set, export my data set, find duplicates, right? And, Claude, Codex, open code, whatever would invoke those skills. Within FiftyOne Enterprise, this is taken a little bit further. So if I go again into quick start here on a data set that I am opening, oh, sorry, this is my EFEM environment. Sorry, let me go back here. Here we go. There is this little agent, little cube in the top right-hand corner. This is a UI version of skills attached to a coding harness, but is side by side with your data in the UI. So here, notice we have Claude Opus 4.8 on the bottom right. We have skills enabled here. And then similarly, I could ask it like, hey, I'll just use the sample thing, find samples with potential annotation mistakes. And this will take quite a bit of time to spin, so I'm not going to do it all here. This is effectively the same that if you were running it with your coding harness, it'll start invoking different tools to analyze the data set, compare ground truth labels against predictions, and then return some kind of result. Usual disclaimer that LLMs are non-deterministic. So, just understand that. All right. All right. So before I wrap up here, just a couple notes. Like I said before, we weren't going to get through all of this notebook. That is by design. A couple additional things I'll leave as exercises to the reader. One is this Z-core utility is kind of cool. It's just a way of performing what's effectively an advanced uniqueness computation on your data to select unlabeled samples that are worth labeling next. It's based off a paper that our machine learning team wrote earlier, actually, I think late last year. So this talks about Z-core. Then there's a couple kind of similar methods it talks about. I demoed in-app annotation separately, but this kind of talks about how you can like use annotation in the app. This is how you can run model inference and evaluation using native 51 methods. There's a section here about using customized dashboards. So in the app, there's a section called, where is it? Dashboards, where you can create kind of arbitrary plots off of whatever criteria you'd like. Maybe like, all the different ground truth detections. And again, these are filterable plots you can use with your to again filter and kind of organize your data further in their distribution. Here again, this is kind of a silly example. It's the ground truth and the Cocoa data set, so it's like all over the place. But again, that's just some of the kind of the custom metrics you can use here in 51. Let me try to reshare my screen here. My cursor got in the way again. I don't know why that's happening. Um, all right. Oh, and then finally, here at the bottom, this is just using the 51 skills and agentic workflows with your coding harness. In this example, it's Claude Code. So again, kind of treat this as an exercise for the reader where if you use Codex or something else, just kind of make the appropriate interpretation. And that's a great note, great comment about using Z-core. Yeah, that's cool that you got that result. All right, let me stop and reshare one more time here. Oh, you know what? That cursor view is actually on my separate screen that I had up. That was actually that screen's actual cursor, so never mind. It's not part of what I'm sharing. Um, all right, so we are at the top of the hour. That covers just about everything I wanted to cover. Again, it was a little bit of drinking from the fire hose, but there really is a lot to the 51 platform. Couple things that I want to make mention of. There's kind of several QR codes I have up here, but I'll kind of make mention of some of the core ones. First is, pointing the 51 documentation again, is kind of your source of truth in terms of how 51 works. That combined with the skills and a coding agent can kind of really help kind of get you onboarded with using 51 because again, just because it is so kind of programmable and composable at its core, there might be a bit of a learning curve. The core repo is actually voxel 51/51, so sorry about that. And then again, we have a Discord community. Community.voxel51.com redirects to the Discord invite. Burhan previously shared the Discord invite in chat as well, and we have this QR code here. And then last but not least, if you want to learn more about 51, we hold a steady conveyor belt of events. So if you go to the events page here, we can see that we have events that are like conference recaps. So if you just are interested in the best of CVPR, for example, and like some of the awesome papers covered there, we have those events coming up. We have a similar one for ICRA. We have both some like 101 and 102 workshops like this one, and then some more domain specific workshops coming up. So again, lots to sign up for, and you'll get all the resources for those as you attend as well. All right. That being said, I'll kind of close myself out here from a content perspective. I know we're about 5 minutes past. Any final questions from folks I could answer before we wrap up? Yeah, like Burhan mentioned, lots of resources in Discord. Remember, there'll be an email sent out with all the workshop resources as well. So think uh, notebook, slides, resources to additional events, some of the docs pages, and like repos that we shared as well.